College Algebra, we are reviewing for an upcoming quiz, quiz number 1 on exponential models. Okay, this was last year's quiz that you're looking at. So what you should see on the quiz should look strikingly similar to this. First of all, if you see there are formulas here at the top, these formulas you should recognize. So the formulas you see here, this is the one on the right, that is continuous interest. When you see a word problem and it has the word compounded continuously, this is your formula. If you see a word problem and it says compounded anything other than continuous, daily, weekly, monthly, hourly, anything like that, that is this one. Okay, so this is your standard compound interest. And your clue in a word problem is to look for how often it's compounded. If it's a piece of time that you can discretely know, like a day, a week, or a month, it's the formula on the left. If it's compounded with the word continuously, that's the formula on the right. So let's look at this. A compound interest is modeled by this equation. So you should be able to look at that and automatically tell which formula is that using. That is continuous interest. So when I come down to this question D, how often is the interest compounded? That is continuously. Okay, so I know that one right off the bat. What is the initial deposit? Remember, in any of these exponential models, this number that you see out front, that is the initial value. So this initial deposit was 30,000. I'm assuming dollars here. So 30,000 is the initial deposit, but in this case you didn't know, so dollars or 30,000 would have been okay. What is the interest rate? So if you look at our formula, it's A equal P e to the RT. So that interest rate, if I look at what I'm given, I see the 0.045. So 0.045, but they asked me as a percentage. So that is 4.5%. So that is my answer. This is compounded at 4.5%. T is the variable time. So remember, this is time in years. So if I look at this equation, I see that 5 right there. That tells me the money was in the account for 5 years. Okay, pretty straightforward. Now below, I'm asking you to calculate interest based on 2 scenarios. So if I had 15,000 for 12 years, how much money would you have if I compound the money daily or continuously? So again, I'm just going to take advantage of writing these formulas as many times as I can, just so that I know what they are. So I'm going to use this for the first scenario, compounded daily, and the second scenario, I'll be using A equal P e to the RT. Okay, so the equation that I need to solve is, so it's A equal P 1 plus R over N to the NT. So what do I know? They're asking me to solve for the future amount. So I know in this case my initial principal is 15,000. I know that the rate of interest is, they're telling me it's 1.85%. So remember, that's 0.0185 when I convert that percent to decimal. And the time, they're telling me is going to be in there for 12 years. So what I need to do, though, on the left side is I need to figure out what is A equal 15,000, 1 plus 0.0185 over, and it's calculated. Now here what we need to figure out is N. So it's calculated interest is daily. So that means 365. So 365 times a year. So it's 365. All of this to the 365 times 12. So that's what I need on my calculator. So I need to calculate all of this. 15,000, 1 plus 0.0185 over 365 raised to the 12th. So if I do that, I'm going to have 15,000 times, parentheses, 1 plus 0.0185 divided by 365, and then outside the parentheses, that is all raised to the 365 times 12 power. So when I enter that, I get 18,728.5. So 18,728.5. And since this is dollars, we typically write it like that. So in 12 years, I will have 18,728.5. Now, if we go to the next question, they're asking me, in how many years will the investment be worth 20,000? So they're asking me, they're giving me the future value of 20,000, and they're saying how long. That means solve for the exponent. So that means that 20,000 is going to equal 15,000, 1 plus 0.0185 over 365, 365t. Okay? So I'm solving for time in this case. Keep in mind, we solve for time with logarithms. So what I want to be by itself is I want this to be all by itself, the expression that's raised to a power. So the first thing I'm going to do is divide everything by 15,000. So when I do that, and just so you can simplify it, get to its simplest form, you can do it on your calculator, but 20,000 divided by 15,000, that's 4/3. That's an easier number to work with. So when I divide both sides by 20,000, I'm going to get 4/3 equal. And now what I'm going to do, I'm going to figure out what is inside the parentheses, that 1 plus 0.0185 over 365. So 1 plus, and that is 0.0185 divided by 365 is 1.00005. So 1.00005 raised to the 365t. Okay? So let me double check that. That was 1.00005. Now, I've got this expression that is the exponential expression all by itself. Now I can take the log of both sides. So the appropriate log to take here is going to be the base. So the log base 1.0005 of 4/3 is equal to the log base 1.00005 of 1.00005 raised to the 365t. Now you should know at this point, and if you don't, you're going to be in trouble in this test. When I look at the right side, the log base 1.00005 of 1.00005 to the 365t, that is just 365t. So what I get here is the log 1.00005 of 4/3 is equal to 365t. I want to solve for t. Now I need to divide everything by what? That is 365. So my final answer is going to be t is equal to the log base 1.00005 of 4/3 divided by 365. And I will use my calculator to figure that out. So that is going to be the log base 1.12345 5 of 4/3. And then all of that is divided by 365, and the answer is 15.76. So I get for this one 15.76, so it tells me it's 15.76 years. That's how long it would take this initial investment of 15,000 to grow to 20,000 at this interest rate. Now, let's look at the next side of this equation. How do I compound this interest continuously at 1.95%? I'm using the continuous interest formula at this point. So my future amount is going to be my initial value, 15,000, and then e to the rate 0.0195 times t. So 15,000 e to the 0.0195 t, but I'm leaving that in for 12 years. So this is 15,000 e to the 0.0195 times 12, and that's where I'll use my calculator. So 15,000 times, and then I will use e raised to the 0.0195 times 12, and that's 18,954.7. So that is 18,954, and those are dollars. Okay, so $18,954.70. How long? That's time. That's the exponent. That's logarithms. So I want to know when 25,000 from my initial investment of 15,000 at 0.0195 t. I'm solving for t in this case. So I need to divide both sides by 15,000. So if I divide both sides by 15,000, and you can carry all of that around, but that's going to simplify pretty easy. That is 5/3. So 5/3, and your calculator will do that for you, equals e to the 0.0195 t. Now in order to solve this, let's create some space here, I need to take the natural log of both sides. So this means that the natural log of 5/3 is equal to the natural log of e to the 0.0195 t. Now what you should recognize, the reason we took the natural log, that's the inverse of the natural exponent. So the natural log of e to the 0.0195 t is just 0.0195 t. It solves for the exponent. So I get the natural log of 5/3 equals 0.0195 t, and now to solve that for t, I divide by 0.0195. So t is the natural log of 5/3 divided by 0.0195, and I will go to my calculator for that one. So I need to figure out the natural log of 5/3 and divide that by 0.0195, and I get 26.19196, 26.2. That's close enough. So this is about 26.2 years. That's how long it would take to grow that investment from 15,000 to 25. So pretty straightforward, but there's a lot of writing and solving solving for a variable or solving for an expression with the logarithm side. So be very careful about your algebra and signs on that. Let's look at this. How much money should I deposit today to have $100,000 in 40 years at an interest rate of 2.41%? This is continuous interest. Okay, I see that I see the word compounded continuously, okay? So how much money should I put in today? They're asking me to solve for P. So I know that in the future I want $100,000, okay? I know that the rate is going to be 0.0241, and I know that we are leaving that in for 40 years, okay? So P is what we are trying to solve for. So I know that this equation is 100,000 equal P e to the point 0.0241 times 12, okay? I need to solve this side for P. That's what I'm solving for. So to solve this for P, I know that P, when I divide both sides by e to the point 0.0241 times 12, so 100,000 divided by e to the point 0.0241 times 12. And I will use my calculator for that. So 100,000 divided by e to the point and what was that interest? 241 times 12. And that is 74,886.2. So 74886.2. So 74886. Those are dollars, okay? So this is the amount of money you must invest today, okay? And then at the end of 12 years, that investment will yield you $100,000. Number 4, the growth of a certain bacteria strain is modeled by this equation. Q equal Q0, that's just a variable. It's like an A or a initial value, where T is the number of hours elapsed and Q0 is the initial population. If there are initially 500 bacteria present, then they're going to ask me a couple of questions. Okay, so if there are 500 initially available, that means Q is equal to 500 and then E to the point 105 T. Okay, how many bacteria are present after 2 days? So T, remember our time is in hours. Okay, so 2 days is how many hours? That is 48 hours. So this is Q equal 500 E to the point 105 times 48. So that will tell me how many bacteria are present after 2 days. So 500, let's put that in our calculator. 500 times E to the point 105 times 48, and that is 77235. So there are 77235 bacteria after 2 days. When will there be 200,000 bacteria? When is time? Time is my exponent. I'm going to need logarithms. When will there be 200,000? So that's when my future value. So I have 200,000 is equal to 500 e to the point 105 t. I'm solving for t. I want this expression to be all by itself, which means I'm going to need to divide by 500. So if I divide both sides by 500, and you can do that in your head, or just to be safe, you've got your calculator. So 200,000 divided by 500 is 400. That's an easier number to work with. So I've got 400 equal e to the point 105 t. Now I will take the natural log of both sides. So the natural log of 400 equal the natural log of e to the point 105 t. You should recognize on the right The natural log of e to the 0.105t is 0.105t. So the natural log of 400 equals 0.105t. Now I need to divide both sides by 0.105. So t is equal to the natural log of 400 divided by 0.105. I will go to my calculator. So the natural log of 400 divided by 0.105 is 57.06. So t is 57.0, what did I say? 57.06. So 57.06. What did they ask me? When will there be 200,000 bacteria? Time is measured in hours. So it is 57.06 hours to reach 200,000. Okay? Moving on, problem number 5. A population is modeled by the equation P of t is 120,000.890t, where t is the number of years since 2000. Is this growth or decay? The key to that is looking at this number right here, okay? That's a number that's less than 1. It's a fraction. So when I keep multiplying that number by itself, everything is getting smaller. It's like 1/2 times 1/2 times 1/2. This is exponential decay. What was the population in the year 2000? That was my initial value. You know the initial value is always that number right there. So that is 120,000, okay? They should all be that easy. Number 6 and 7. So let's look at number 6. The amount of nicotine in the bloodstream after vaping is modeled by this equation you see. T is the number of hours after vaping, and the nicotine is measured in milligrams. How much nicotine is in the bloodstream upon initial vaping? That is the initial value. So that is 10 milligrams. How much nicotine is in the bloodstream after 5 hours? So that is when I substitute T equal 5. So N is equal to 10 e to the minus 0.4 times 5. So I will use my calculator for that. 10 times e to the minus, what was it, 0.4. So minus 0.4 times 5 for 5 hours, so 1.35. So that tells me 1.35 milligrams after 5 hours. Okay, so we started with 10 milligrams. After 5 hours, there's 1.3 milligrams of nicotine still in the blood system. The nicotine will be negligible when it reaches 0.5 milligrams. How long? That's time. That's exponents. That is a logarithm that you know and love. So how long until it reaches 0.5 milligrams? So when do I get to 0.5? I started with 10 e to the minus 0.4 when I'm solving for time. So in order to do this, I've got to use a logarithm. First thing I would do is divide both sides by 10. So I get 0.5 over 10 is equal to e to the minus 0.4t. I will take the natural log of both sides. When I take the natural log of the right side, that is just minus 0.04t, minus 0.4t. So the natural log of 0.5 over 10 is equal to minus 0.4 over t. Divide both sides of that by negative 0.4. So t is the natural log 0.5 over 10 divided by negative 0.4. I will use my calculator for that. So the natural log of, what was it, 0.5 over 10. Natural log of 0.5 divided by 10. all of that gets divided by negative 0.4, and that gives me 7.49. So that tells me that 7.49 hours, okay? So 7.49 hours to reach that negligible rate of nicotine in the bloodstream. Instead of going to college, you decide to make your fortune creating viral, there should be the word math videos for YouTube. Viral videos create ad dollars for the poster. A video is said to be super viral if the number of views can be modeled by this equation, where V is the number of views in millions and T is the time lapse. How many days will it take for your super viral video to reach 20 million? Okay, so here are key things. My formula is in hours and they're asking me about days. Okay, so I'm gonna have to do some kind of conversion. So super viral means it reaches 20 million. So when does 20 equal e to the 0.0404t? Okay, so 20 is equal to e to the 0.0404t. To solve this, I'm going to take the natural log of both sides. When I do that, this right side, that condenses pretty nicely. So this means the natural log of 20 equals 0.0404t. I want to solve that for t. So t is equal to the natural log of 20 divided by 0.0404. And I will go to my calculator for that. So I will take the natural log of 20. That gets divided by 0.0404, and that gives me 74.15. So this is 74.15 hours. But they asked me, how many days is that? Okay, so 74.15 hours. How do I convert hours to days? So 74.15 hours. Remember, there are, 24 hours in one day. So when I divide that number by 24, so I take this number that I just received and I divide that by 24, I get 3.09 days. So 3.09 days, okay? And there we go. That is the end of the review. If you can work through this and understand, especially the stuff with logarithms, be very methodical about what you're doing and not make mistakes, you should do well for this.